here we've been given the axis of symmetry is -3. We know that that has to do with the vertex, but we don't have the y-coordinate of the vertex, and we've been given 2 random points. So I'm just going to try to sketch this graph. Okay, so I have x equals -3, maybe about here. That's going to be my axis of symmetry. And at 2/6 up, somewhere around there, 7/6 up, or 7/21, maybe somewhere around, let's say right about here. Okay, so at this point we don't really know, it's hard to tell if this is upside down or right. So I haven't really graphed this very accurately either. I suspect maybe, we could maybe hypothesize that the graph looks something like that. Okay, it's really hard to tell though. Okay, because it looks like this point is maybe a little bit closer. So this graph is going to be upside down like that. Okay, we're not too sure. So we're just kind of hypothesizing. So how do we set this up algebraically? Okay, so again, the physical characteristics should give us some indication of the algebra involved. So I'm going to try to use graphing form when I can. Okay, so I'm going to go y equals, I don't know a, I do know that the p value though, so I'm going to go +3, make sure you use a squared, plus q. So this point, that's all I know so far, and I have 2 unknown values. But I do know that I can plug these coordinates into x and y. But the problem is if I plug 1 in, I still have 2 unknowns. But if I have 2 unknowns, you should think right away, I need 2 equations to solve this as a system. So I'm going to set up my 2 equations by plugging in my 2 coordinates. So one equation is going to be generated by substituting in 2 and 6. My second equation is going to be generated by plugging in the 7 and 21. This is not +5, it's +3. +3 squared plus q. So when I solve for this, I'm going to end up with 25a plus q. Here equation 2 is going to be 100a plus q. The nice thing is I have my 2 variables, I have my 2 equations, and the q's match up. So I'm just going to take equation 1 and subtract it from equation 2. So I'm going to take my equation 1 here and go subtract that from equation 2, and that's going to give me 15 is equal to 75a. The q's cancel out. I am able to solve for a. A is equal to 1/5. Is that positive 1/5 or negative 1/5? So 21. So it looks like it's positive 1/5, if I'm not mistaken. 21 minus 6. Yep, that's going to be positive 1/5. So it looks like my graph is going to be more like that. I don't know. Not too sure I can graph this, but okay, something like that. Kind of hard to draw. I don't think I drew this original point very well. Okay, so that's going to be my a value. I need to then solve for q by plugging back in. So I'm going to just plug it back into equation 1 and say that the a value, so that's 25a, my a value was 1/5. Solve for q. Looks like q is equal to 1. Okay, so when I sketch in this graph now, I know where my vertex is. It's going to look something like that and something like that. Okay, so there's my parabola. I've got solved for all the parts. I now just need to write my equation. A is equal to 1/5. P is equal to -3 and Q is equal to 1. So there's my equation of my parabola. So how did I do this again? Well, I used setup. I've given the axis symmetry, so I decided to use the graphing form. Now the graphing form isn't always going to be the best choice, okay, but it's the one that we would like to use if possible. If this would work actually if we tried using some other one of the other forms, but again, this kind of leans towards the graphing form. Once I decided on that, I plugged in my known parts. I have two unknowns. I had to set up two equations to have a system of equations. I did that by using these two coordinates, and I solved this as a system of equations. Okay, so here I've been given the equation, okay, in graphing form, so I know what this looks like. I'm asked to find a symmetrical point, 2, 4, 7. Let's first of all, let's just draw this in. So 3 over 5 up, maybe somewhere around here. It's going to be parabola, it looks like that. And we're talking about a symmetrical point, so we're going to do that. And at 4 over 7 up, 4, 7, that's going to look like that. And I'm being asked to find the symmetrical point over here. Okay, so we could probably just count this, right? So it's 1 over this way, 1 over this way, so that should be 2, 7. Okay, so that's perfectly fine. We can just solve it in that way. And we could use this line of symmetry to do that. So I'm going to show you a few different ways we can do this as well, other than just visually and kind of just doing it more or less kind of informally. To formalize this a little bit, which is important, we really want to formalize this. So I'm just going to say this. I'm going to just call that point A. And to formalize this, what I could do is this. I know that there's a relationship between the symmetrical points and the middle point, and the relationship looks like this. That if I add the outside points, A plus 4 and divide it by 2, I'm going to equal the middle. Right? This is a formula to calculate average or middle. Okay, so this is a very useful thing to use, especially for parabolas, since they are symmetrical, and you often can find a relationship with middle. So this is my average. So if I want to solve for A, I just algebraically rearrange this. I get A plus 4. A plus 4 is equal to 6, and that makes A equal to 2 when I solve this algebraically. Now, why would we do this? Well, this is easy problem to do kind of informally, but once we start dealing with unknown parts, we really need to understand the relationship. And what is the mathematical relationship? What is the math involved in this relationship? And it's really important to understand the mathematical principles behind this idea of symmetry. And so this is a nice, simple way to be able to use that relationship, but we have to recognize that relationship first. So I want you to be able to connect this idea of middle to this idea of middle, the average formula to the idea of middle algebraically. The other way that this could have been done, okay, so this is now a separate method. What I could do is solve this algebraically because we always can plug this coordinate into back into our equation. Now, we don't want to plug 4 and 7 in. We want to say, well, there is some coordinate A7 that is on this parabola. Okay, and then we can plug that coordinate in. I'm just going to do this in green here. I'm going to say that's A, and we're just going to say that A and 7 are on this graph. So y equals 7, x equals A, and then I can actually just solve this. So this is method 2, and I could solve this. I get 2 is equal to 2a minus 3 squared. Okay, this is going to be equal to 0. Sorry, equal to 1. divide by 2, and I get a minus 3 squared equals 1. Well, a minus 3 can equal plus minus 1. Okay, so I'm going to write this as two separate equations equal 1, or a minus 3 can equal negative 1. A is equal to 4. Well, I already knew that because that was given to me at the beginning. But the other a here that I'm solving for, a equals 2. That's the one I'm looking for. So we could have solved it algebraically like this. This is kind of a brute force method. It does work, but it's not very useful, and it gets difficult to use once you get to harder problems. This is a much better method, I think, because we're actually looking at the math behind this and then using the property of symmetry. Here we're just using kind of brute force algebra. Well, we can just plug in things and just kind of see what happens.